Okay boys, so I'm going to talk you through this investigation here that shows us how experimental probability is calculated, and also is going to show us how hopefully it gets more accurate, closer to what you'd expect, the more times you carry out the experiment, in this case flipping a coin. So I've got my 50p here. If I flip it once, it could easily be heads or tails. It won't be a surprise if we get tails. But if I flip it 160 times and I say only got 2 tails, you might be a bit suspicious, because with 160, you'd expect we should get 80 heads or 80 tails, but that's not necessarily likely to happen. Anyway, although we know the probability of getting a heads is a half, we're just going to carry out an experiment to see how close we get to a half. Okay. One thing you've got to remember for this lesson compared to the last lesson was you were doing something called relative frequency, and that is the same thing as experimental probability. Okay, it's just a fraction. Anyway, more on that later. I'm now going to flip my coin 20 times and I'm going to record up here what we've got. I've never done this before, but I'll see if I can speed up the video before I post it on YouTube, but that'll be an experiment for me. So here I go. Heads. 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 Classic maths teacher, I've got evens, 10 and 10. So that's 20 flips and I've got 10 and 10. That's well, unsurprising. So after 20 flips, okay, the experimental probability of getting a heads, and I'm going to write this like this, P bracket heads bracket, is, well, I got 10 heads out of the 20 flips. Okay, and hopefully you already know what that is as a decimal, but you can divide 10 by 20 on a calculator and you'll get 0.5. Okay, so now on my graph here above 20 I can plot 0.5. I made the mistake of using a Sharpie, thinking that it would make it easier for you to read, but well, looking at that, that's supposed to say 1.0, it's not the easiest to read. Anyway, hopefully you can read it. So there's my data. After 20 flips I've got 0.5. What I then want you to do is get someone else's data and add it to yours. Now, if you're using Microsoft Teams, which I would like you all to use, but I think there's some of you that don't, you can post your data on Microsoft Teams and you can take other people's off of there. If you're not on Microsoft Teams, a little bit later on I'll start emailing some people's data to all of you so that you can see it that way. Anyway, there are many ways you can get hold of the data. You can directly contact your friends in the class to get their data. But anyway, I'm going to add someone else's data to mine to show you what would happen. So looking on Microsoft Teams, I know that someone else has already posted their data nice and early this morning, and they got 11 heads and 9 tails. So if I add theirs onto mine and pop that, say here, look, 11 heads and 9 tails, that now gives me a total of 21 heads and 19 tails. But it's the 21 that's important. So after 40 flips now, because I'm including someone else's 20 with my 20, I've got 21 out of 40 is my new probability. Okay, now we don't know what that is as a decimal, and nor do I, so I shall get a calculator and we'll work it out. So So let's have a look. 21 divided by 40. I've managed to find the only calculator in the house that doesn't work. (21) you can't see that, there we are, divided by 40 equals like that, SD. So I press the SD button, this one here, I'm sure you know about that, and we get 0.525. Okay, well, that's got a slightly fine margin now, but 0.525 is slightly above 0.5, isn't it? So I'll just try and put a dot slightly above there, okay? And then we'll add on someone else's data and see how we get on. So that will be what happens from here onwards. You get someone else's data so that you'll get after 60, and you'll add that on to a list here, and then you'll see how many heads you've got in total with 3 people's data, and you'll calculate a new probability and plot it. Now it might be that this axis is a bit too squashed. I think if it was me and I'd been writing this book, I would have made this axis a lot bigger, maybe going up in 0.1s or even 0.05s. So if you haven't actually done this yet, you might be better off drawing a much bigger vertical axis going up in 0.1s. Alright? Particularly if you're doing this in your exercise book, if you do it with only those small squares going up in 0.2s, you'll find it very hard to draw the dots, you know, that close to each other. So I would stretch this axis out, okay? I would get it going up in 0.1s or even, as I say, 0.05s. If you go up in 0.05s, you'll need 20 squares going up. If you go up in 0.1s, you'll need 10 squares, okay? Anyway, so once you've done this, you'll have plotted a graph which in theory should sort of level off, so that when you get up to these higher numbers of flips, it definitely gets closer to 0.5. I think me and this other person here have kind of, our flips have been a bit boring. They've been what you'd expect to happen. There'll be some of you in the class who'll get very different numbers to 10 and 10 or 11 and 9. There's bound to be someone who gets 16 heads and 4 tails, and hopefully they're being honest with the rest of us. Alright? Okay, well, I think I'm going to leave this video here because I've got to go and work out how to speed up the coin flipping. What I'd like us to do is do a similar experiment, which is a bit different to coin flipping, where we actually don't know the probability that's going to come out of it before we start. But I've got to put some thought into what that might be, and we might do something similar like this again. I might get you to sort of repeat something many times and we'll pool our data, but you'll have to let me think about that. Good luck, boys.